Ellerby Creek is a heavily polluted creek that runs through Durham, North Carolina. Typically, the trash in Ellerby has been cleaned through volunteer efforts, but this solution requires too much time and effort to be sustained. Our team was approached by the Ellerby Creek Watershed Association, ECWA, and asked to create a device to help extract floating trash along a stretch of the creek that runs through the publicly owned Hillendale Golf Course. The device is expected to sit in the creek for around 2 to 3 years.
The goal of our project is twofold. First, we aim to collect trash. Removing the floating waste from the stream is vital, since this water flows directly into Falls Lake, which is the primary drinking supply for Raleigh, North Carolina, a city of over 460,000 people. The second goal of the project is to provide a method for maintenance and data collection. ECWA's request was to create a proof-of-concept design that could provide data that could drive legislation to resolve the problem. They will also keep track of the status of the device to see what works in order to implement similar and improved solutions across other tributaries.
Our overall goal this semester was to install the device into the creek. In order to do that, there were other goals and expectations we needed to meet. First, we needed to adjust the buoyancy since the device didn't submerge quite to the desired level. Second, following conversations with our client, we wanted to improve the attachment to land to make it more user-friendly. Next, to legally install it, we had to determine if a permit was necessary, and our responsibility in this process was to make a CAD model of the device. Next, to ensure that our device was used and maintained properly once it was in the water, we aimed to write a maintenance plan. Finally, we hope to continue testing and fix any further potential failures. Once all of this was achieved, we would install it into the creek. In order to adjust the buoyancy, we added 19 pounds of sand into 2 PVCs on the bottom of the cage. To improve the attachment to land, we used coated airplane cable, integrated strong carabiners, and designed the connection between the device and the trees in a way that would naturally adjust to the changing water levels. The next thing we did was create a SOLIDWORKS CAD model, which we presented to the Army Corps of Engineers, who decided the device didn't require a permit. We conducted a series of tests to make final adjustments, and we confirmed the buoyancy, tested the strength of the wings, tested the durability of the attachment to land, and simplified the trash removal process. We created a failure modes effects critical analysis and conducted a technical meeting to confirm the results. This led to alleviation of potential failures. We reinforced the wings, adjusted and secured the net, reduced wildlife threats, and added protective measures to the bottom of the device. Lastly, we created a user manual and installed the trap.
There are 3 main design blocks that we considered when building our final prototype: the cage, wings, and attachment to land. The following slides will describe the purpose of each of these design blocks, as well as the modifications the team made to these blocks this semester.
The cage's function is to collect and store trash. It is constructed out of 2-inch and 3/4 inch diameter PVC, netting, hose clamps, pool noodles, and paracord. We made many modifications to the cage this semester. For one, we doubled the net and sewed it together to add strength. Then, we refastened the net entirely internally, so there wasn't any net on the bottom of the PVC, which would reduce risks of it getting stuck or experiencing abrasion from the stream bed. We also re-sewed the net together with black paracord rather than fishing wire to appease the environmental concern of wildlife getting trapped in the transparent wire. On top of that, we added rubber and cork blocks to further reduce any destruction of the PVC from the stream bed. Lastly, we added about 20 pounds of sand to the middle 2 PVC pipes, shown by the green arrows, to make it float at the correct height.
The function of the wings is to guide trash into the cage. There are 3 5-foot-long PVC pipes of 3/4 inch diameter. The top 2 pieces of PVC are covered with pool noodles. The wings experienced some modifications this semester. After testing the strengths of the wings, we noticed that they are not likely to snap, but they could bend significantly. To reduce the ability to bend, we added airplane cable to the device that holds the wings with tension so they can only bend a few inches. The only other modification this semester was attaching the other wing, which we did on site because of transportation convenience.
This semester was critical in the development of our attachment to land mechanism. The main modification was the way in which the airplane cables would hold the cage. We designed it so that there is one continuous loop that connects from the top of the 2-inch PVC vertical pipe, extending to a carabiner hooked around the tree base, and then back to the bottom of the PVC pipe. This one-cord technique allows the trash trap to oscillate vertically with a change in creek water level. The carabiner is crucial for the ease of maintenance, in that to move the trap to the side of the creek, all you have to do is unclip it. We also added hoses to surround the airplane cable around the tree so the metal doesn't erode into the wood. The last major advancement was that we visited the site to verify which specific trees that we would use.
Our current trash trap has 5 major strengths. It is cheap, easy to replace, easy to access, durable, and varies with water level. Our device is mainly built out of PVC, pool noodles, and net. All 3 of these things are inexpensive and easy to purchase at any store. Our device also has a relatively simple design. There are no mechanical components, and in essence, it is a very large PVC box. The open-top construction of our device means that trash is easily removed by volunteers using trash pickers. The device is also very durable. The 2-inch PVC used has a tensile strength of 924 pounds, making it a good choice for our device. Finally, our device is designed so that it may move to different heights depending on the water level. This design choice serves the dual purpose of allowing our device to capture trash at all times, as well as reducing stress on the overall structure. Despite these successes, there are a few shortcomings. Our device is very heavy, and as a result, it is difficult to transport. Also, our device has been designed specifically for the stretch of the Ellerby Creek that runs through Hillendale Golf Course. The width of our device, attachment to land, and the lengths of those attachments were all chosen and measured specifically for our location of deployment. Finally, our device does not span the entire width of the creek at all levels. The trapezoidal nature of the creek makes it difficult to do so, as the device moves up and down. So the result of this, we fear, is that some trash may be allowed to pass. All of these limitations would need to be considered in future iterations of the trash trap.
So here we are on site at the Hillendale Golf Course. We have the ECWA team here. I'm currently in the creek, and here's our installed trash trap. We have the airplane cables extending to the base of this tree here, where we have a carabiner attached to some pieces of hose so that doesn't erode the tree. Relatively taut, we left a little bit of slack so that when the water rises, the trap can actually extend up with that water flow. And over here you can see we have the same thing on the opposite side. We have these runners here sitting at the bottom level of the pool noodles as intended. And then we have these extra airplane cables here you can see that go up and around the center of the trap and then back down, just so that the runners, when pushed out, can flex back and they don't get overextended. So here's our installed trash trap. Project is complete after about 8 or so months, so we're very excited to be here and that it is done. Now, Kevin, smile.